So, welcome to the next lecture of linear algebra. Today we are going to discuss differential equations. We started in the previous lecture. I gave you a brief introduction of the differential equations. We discussed where do these equations come from, how can we derive them by using a simple given function. For example, on this slide, on slide 2, I gave you two examples. Let me admit people. Yes, I give you two examples, one on the left hand side and the second is on the other side. There's a question in the chat window: do we need to send our work for the midterm? Kindly ask these kind of questions after the lecture. During the lecture you just ask the questions related to the topic. I request you. So these were the examples we discussed in the previous lecture. If we are given y is equal to, if we are given y is equal to this one, let me turn this thing on, this one, we can take its derivative and then using again its value y, we can obtain an equation which involves the derivatives, which involves derivative of a function. So this equation is called a differential equation. So informally, a differential equation is an equation which involves the functions and its derivatives. So this equation on the left hand side, it involves only one derivative. But on the right hand side, if we consider this function, we take its two derivatives, then we can replace sine 4x by y, and we get this equation which involves the two derivatives. Here we must have plus. There is a typo mistake here. When we take this on the other side, this will become plus. So we have this differential equation which involves the two derivatives of the function. So an equation which involves the derivatives of a function is called a differential equation. So this is an informal definition of the differential equation. So what is the major thing we want from differential equations? If we are sorry. Yes, Adnan Saeed, you have raised the question. Go ahead, ask your question. Yes. पहले अपना mic on करें kindly.
Can you hear me?
Yes, I can hear you.
Can you hear me?
Yes. Go ahead.
Sir, you said in differential equation हमें जो resultant आता है उसमें हमारे पास original function, but in polynomial equations हमारे पास original function आना impossible है क्योंकि वो further उसको simplify कर देगा. Trigonometry और exponential equations में तो possible है, but polynomials में किस तरह होगा?
It's just an idea I'm giving you. Not always for any function we can construct a differential equation. It is not always possible. Okay. This is an idea which I gave you, how we can construct differential equations by using different functions. It is not always possible that we can make a differential equation from any function. Okay, there are some specific kind of functions for which we can obtain these kind of differential equations. Okay. So if we are not given any function and we are only given these kind of equations, for example, this one and this one, what we want from these equations, we need to find this function y, which is unknown in this differential equation, and we have to find this function out of this differential equation, which will be called the solution of a differential equation. It means we go backward. If we are given the differential equation, we have to find the original function which satisfies this differential equation. So for example, on this slide, if we are given this differential equation, in this part of the course, we will learn that how to find this original function which satisfies this differential equation. For example, if you insert this function, if we insert this function in this equation, We take the derivative, we insert the y here, we take its derivative, and we take 6x, and then we put the y. Both sides should be equal. This equation should be satisfied. We'll discuss this further in detail in the next slides. So, what we want from differential equation? We want to find the solution of a differential equation. We'll discuss it physically as well, how we can obtain differential equations from physical problems, or how we can translate physical problems into a mathematical equation, which is a differential equation. So informally, the definition of a differential equation is informally an equation that involves the derivatives of functions. You can see here that the functions could be unknown functions. It can be one, it can be more than one, is said to be a differential equation. So this is basically informal definition of a differential equation. Now we go towards the formal definitions or formal definitions of differential equation. Now, on this slide number 4, I gave a formal definition. Definition 1 is what? An equation containing the derivatives of one or more dependent variables with respect to one or more independent variables. So, in any equation which we call a differential equation, it can involve dependent variables as y, u, v, and in that equation, or you can say that equation involves the derivatives of dependent variables as well, with respect to x, with respect to y, or with respect to t, if we assume that x, y, and t are independent variables. So an equation involves an equation containing the derivatives of one or more dependent variables with respect to one or more dependent variables is said to be a differential equation. This is the most general definition of the differential equation. So, for example, now there are, I'm giving examples. Yes, here. Now, there are two kinds of differential equations if we classify them in general. One is the ordinary differential equation and the other is partial differential equations. Now, these two bifurcations or types of differential equations are very important. In this course, we shall only discuss the ordinary differential equations, this one. Now, in the second definition, I gave you the definition of ordinary differential equation. If an equation contains only ordinary derivatives of one or more dependent variables with respect to a single independent variable, it is said to be an ordinary differential equation. If you have any question, you just raise your hand. Saf raised the hand. Go ahead, ask your question.
सर आपकी ऑडियो हैंग कर रही है.
Audio hang कर रही है. Just give me a minute. I'll check my internet.
Okay.
Just wait 1 minute. So I'm back. Can you guys listen me now properly?
Yes.
Hello. Yes. Okay. Then now in this course we are going to discuss only the ordinary differential equation. This was what I was talking about. Now the ordinary differential equation is an equation which contains only the ordinary derivatives with respect to single independent variable. Ordinary derivatives are simple derivatives which we study in calculus 1, in single variable calculus. An ordinary derivative is that derivative in which only one dependent variable and only one independent variable. This one. This is called ordinary derivative. whereas the partial derivative is something different. We'll discuss it later on. Then if an equation which involves only the derivatives of one or more dependent variable with respect to a single independent variable, then it is said to be ordinary differential equation. Now, the examples are this one, which we had derived on the slide number 1. This could be a differential equation. It involves only dy by dx, ordinary derivatives. So these are differential equation. This is again differential equation. You can see here that it is not always, you can say y is only the dependent variable. Dependent variable could be different. This one is dependent variable and this t is independent variable. Okay, you know, we take the derivatives of dependent variable with respect to independent variable. In this equation, this is dependent, this is independent variable. Now, in this equation, you can say this is dependent and t is independent variable. You can take any dependent or independent variables. Now, in this equation, you can see there are two dependent variables, u and v, and this equation involves the derivative of u with respect to x and derivative of v with respect to x. There are two dependent variables but only one independent variable. So according to the definition of the ordinary differential equations, an equation which contains only ordinary derivatives of one or more dependent variables, one or more. So in this equation, there are two dependent variables, but we have the derivative with respect to only one independent variable. So this is again a differential equation and it is ordinary differential equation. I hope you got it. If you have any question, you can ask me. Let's go to next slide, which is slide number 5. Now, the other kind of differential equations are called partial differential equations, and we call them PDEs. Okay, an equation, its proper definition is an equation involving partial derivatives of one or more dependent variables with respect to two or more independent variables. It is called a partial differential equation. So the examples you can see here, these are partial differential equation. For example, in this equation, you can see that there are two dependent variables and two independent variables. One is x and the other is y. So these kind of derivatives are called partial derivatives, and if an equation involves partial derivatives, then it is called a partial differential equation. But in this course, we shall only discuss ordinary differential equations. Now, other notations, differential equations are basically denoted by a different kind of notations. You can see here on this slide number 6 that this differential equation, this one, d square y by dx square minus sin x dy by dx plus 16y, this can also be written in this way, which is y double dash, instead of d square y by dx square, we can write y double dash sin y dash, and also we can write in this way, we can write d square y. D square stands for second derivative. D square stands for d square. Let me check this thing. Yes, d square stands for d square by dx square. So it's the same kind of differential equation which we had defined here. Also, if we have this kind of differential equation which involves t only, t as a time, t is the independent variable, x is the dependent variable, and in physics or many of the engineering subjects, for example mechanics, we denote such kind of differential equations by this notation where x double dot is what? X double dot is second derivative of x with respect to t. So x single dot is single derivative of x with respect to t. So in different subjects we denote equations by different notations. I hope you got it. Similarly, partial differential equations are denoted by, yes, anyone has any questions? Or how do we know that its variable is dependent or independent? So it's obvious. If the variable is in the numerator here, it is dependent. This is what? This is dependent variable. You know how to take the derivatives. This is dependent. And in the denominator, it is obviously independent variable. I hope you got my point. X double dot, yeah, the question is double dot is only with respect to t. Yes, normally. Basically, double dot notation is used usually in mechanics. You might have studied the mechanics and you have studied these kind of differential equations, which simple harmonic motion आपने पढ़ी होगी, pendulum motion पढ़ी होगी. उसमें जो differential equations हैं, they are basically usually denoted by x double dot. X double dot is always, you can say, the derivative with respect to time, because this notation is usually used in physics, particularly in mechanics. So the partial differential equations are basically, they can also be denoted in this way, where partial square u by partial x square, we can write this thing in this way: u subscript xx. If there are two x here, it means it is a partial derivative with respect to partial derivative, second partial derivative with respect to x. X means two derivatives. Y means two derivatives. Here you can see that partial square u by partial t square is partial tt, and here you have partial u by partial t, and in the subscript we can only write t one time, and similarly this one. So these are the different notations we use for ordinary differential equations and partial differential equations. If you have any question, you go ahead, you can ask me. Now let's go to the classification of differential equations. Yes, Adnan Saeed, you have raised your hand. Go ahead, ask your question.
So the maximum degree of differential equation is 2 in differential equation.
No, it's not always compulsory or necessary. It can degree. Now we are going to discuss how can we classify differential equations with respect to order, degree, and linearity. In this classification, I'll explain you what is the order, what is the degree, and what is linearity of differential equation. I hope you understand these things in the upcoming slides. Okay. So now we are going to discuss how can we classify these differential equations. So there are three major classifications that we can differential equations. We can bifurcate them. For example, the first one is order of a differential equation. We can classify them with respect to order, with respect to degree, and with respect to linearity. Now, what is the order of a differential equation? Order of a differential equation, either it is ODE or PDE, is the order of the highest derivative in that equation. Now, for example, in this equation, what is the order of derivative here? It is 2. The order of this derivative is 2 here. Now, order of this derivative is what? 1. Because the order of derivative is important, not the power or degree of a derivative. So order of derivative here is 1, order of derivative here is 2. So overall, the order of a differential equation is 2. So here in this equation, what is the maximum order? This is the first order. There is no other derivative. So this differential equation is of order 1. I hope you got my point. So next, we are going to discuss what is the degree of a differential equation. The degree of a differential equation is either either PDE or, sorry, let me this one. Yes, this one. The degree of a differential equation, either it is ODE or PDE, is the power of the highest derivative in the equation. Keep this thing in your mind. Power of the highest derivative in the equation. Now, what is the power of this derivative? It is 1. What is the power of this first derivative? It is 5. Now, according to the definition of the degree, what will be the degree of this differential equation? The power of the highest order derivative, which is 1 here. So its degree is 1. Now, what is the power of derivative in this equation? The highest order derivative is dy by dx, first order, and its power is what? It is 3. So its degree is 3. Now, in this case, what is first? The higher order derivative is this one, and what is its power? Its power is 3. So 3 should be the degree of that differential equation. I hope you got my point. What is the degree of a differential equation? Yes, any question? If you have any, why not 5 for the first one? Because 5 is the power of the first derivative. And according to the definition, what is the degree of a differential equation? The degree of a differential equation is the power of highest derivative in that equation. So what is the highest derivative? It is d square by dt square. This is the highest order derivative. And its power is what? Its power is 1. So that is why the degree of a differential equation is 1. I hope you got it. So now the next one is linearity of the differential equation. How can we classify the differential equation by using its linearity? Now, what is the linearity of differential equation, or how we can say that the given particular differential equation is linear or not, or it may be non-linear. If it is not linear, we call it non-linear. Now, a differential equation, either it is ODE or PD, is said to be linear if the dependent variable or variables is linear in each term. Is linear in each term. For example, is linear means its power is 1. Okay. Dependent variable is linear means its power is 1 in each term of the differential equation. For example, here the power of y is 1, here the power of y is 5. So it is not linear here in this term. Here the power of y is 1. So it is linear in the third term. But in the second term, the power of y is 5. So it is non-linear differential equation. In this equation, you can see the power of y is 1, the power of y is 1 here, the power of y is 1 here. So in each term, the power, or you can say the degree of y should be 1, then it is called a linear differential equation. So in this equation, every power of y, or you can say y is linear in each term, so this is linear. In this case, in the third equation, here the x is dependent variable. So power, we need to check the power of x. So x power is 1 here, 1 here, but here what is the power of x? It is 1 by 2. So it is not 1. So this differential equation is non-linear. You can see now the fourth differential equation. In fourth differential equation, the power of y dependent variable is 1 here in the first term, and here you can see this is your cos of y. Now cos of y is a non-linear function. It is not a linear function because you can see cos of y can be written in this way in the series form. Now cos y involves power 2, power 4, and power 6, and so on. So this cos y is not a linear function, not linear. So this differential equation as a whole is now non-linear. I hope you got my point. If you have any question, you can ask me. What about sine y? Sine y is also non-linear function. If it is involved in any equation, it will not be linear. Similarly, e raised power y again involved, and e power y is also not linear. So it won't be a linear differential equation. Adnan said yes. You go ahead, ask your question.
So what about exponential equations?
Exponential agar function dependent. We need to see dependent variable only, नॉट इंडिपेंडेंट वेरिएबल। अगर यहाँ पे साइन यहाँ पे अगर लिखा होता साइन x टाइम्स y, ठीक है, साइन x सेपरेट फंक्शन है, देन पावर ऑफ y इज 1 सो इट इज लीनियर। जैसे कि यहाँ पे साइन x इट डजंट मैटर, साइन x इट डजंट मैटर। अगर यहाँ पे फॉर एग्जांपल अगर ये लीनियर है, मैं इसके साथ यहाँ पे लिख दूं e raised power y, so it becomes non-linear because e power y is not a linear function, it is a non-linear function. Linear function कौन से होते हैं? I hope you know. A function whose graph is a straight line is a linear function. जैसे linear equations होती हैं. So all other functions of this kind are non-linear functions. Its graph is not a straight line. So अगर इस तरह के functions, if they are involved in the differential equation, then differential equation is not linear. For example, in this equation, square root of x, is it a linear function? No, it is not a linear function. So this differential equation is non-linear. Yes, somebody has raised the hand. Somebody had raised the hand. What do you want me to repeat? You just ask me the question, Batul.
सर सेकंड इक्वेशन में y डिपेंडेंट वेरिएबल है,
हाँ, सेकंड में y.
तो आपने e की पावर कुछ लिखा था, वो तो आपने x की 4 के साथ लिखा था। अगर y
नहीं,
के
e
साथ
raised power y है ना, यहाँ पे e raised power y है अगर,
जी,
ठीक है, तो y डिपेंडेंट वेरिएबल है ना, तो ये फंक्शन डिपेंडेंट वेरिएबल में है, ये लीनियर नहीं है, तो ये नॉन लीनियर इक्वेशन हो जाएगी। हमने सिर्फ y डिपेंडेंट वेरिएबल को देखना है। यहाँ पे पावर 1 है, यहाँ पे पावर 1 है, यहाँ पे पावर 1 है, ठीक है, यहाँ पे पावर 1 नहीं है, तो ये नॉन लीनियर। जहां जैसे यहाँ पे x डिपेंडेंट वेरिएबल है ना, तो यहाँ पे x को आपने देखना है, फिर सारी जो टर्म्स हैं x की, या सारी टर्म्स में x की पावर क्या होनी चाहिए? 1 होनी चाहिए, x लीनियर होना चाहिए। Then we say that this differential equation is linear, otherwise we call it non-linear. Dear Batul, if you have any question, you go ahead. Awaz, you go ahead. Ask your question.
सर सारी पावर 2 हो सकती हैं? अगर सारी पावर 2 है तो लीनियर होगा?
नहीं, लीनियर मीन्स व्हाट? लीनियर
सिंगल पावर
वही फंक्शन होता है जिसका ग्राफ स्ट्रेट लाइन हो, ठीक है। अगर पावर 2 आ गई फंक्शन में किसी भी वेरिएबल की, तो वो ग्राफ लीनियर नहीं रहेगा, ठीक है, यही होता है ना। सो हमने देखना है
हाँ,
डिपेंडेंट वेरिएबल की पावर 1 है हर टर्म में। दिस इज व्हाट वी हैव टू चेक। यस, नेक्स्ट वन, आस्क अ क्वेश्चन। Someone has raised the hand. Adnan Saeed, yes.
सर पार्शियल डिफरेंशियल इक्वेशंस में डिपेंडेंट वेरिएबल्स मोर देन वन हो सकते हैं?
Yes, डिपेंडेंट वेरिएबल दोनों में मोर देन वन हो सकते हैं, ऑर्डिनरी में भी, पार्शियल में भी। ऑर्डिनरी में इंडिपेंडेंट वेरिएबल सिंगल होना चाहिए, पार्शियल में इंडिपेंडेंट वेरिएबल मोर देन वन होंगे, ठीक है। Any other who has raised the hand? I cannot see your names. Please, you go ahead, ask your question.
Excuse me, sir.
Yes.
सर अगर एक इक्वेशन में दो वेरिएबल्स हों y और x, और उसी इक्वेशन में dy by dx भी हो और dx by dy भी हो, तो पता कैसे चलता है कि कौन सा डिपेंडेंट है और कौन
ऐसा
सा
पॉसिबल नहीं है, इट इज नॉट पॉसिबल। ये नहीं हो सकता एक इक्वेशन में dy by dx भी हो और उसी इक्वेशन में dx by dy भी हो, तो फिर पता कैसे चलेगा इंडिपेंडेंट कौन सा है? डेरिवेटिव्स में जब आप डेरिवेटिव फाइंड करते हैं तो आपको पता होता है ना कि डिपेंडेंट कौन सा है y और इंडिपेंडेंट कौन सा है x। हम डेरिवेटिव फाइंड करते हैं y का विद रिस्पेक्ट टू x, तो x उसमें इंडिपेंडेंट होगा, y डिपेंडेंट होगा। दिस इज हाउ वी टेक द डेरिवेटिव्स, ठीक है। तो ये तो हो ही नहीं सकता कि आप एक इक्वेशन में dy by dx भी हो और dx by dy भी हो, इट इज नॉट पॉसिबल। Yes, Fawaz Ahmed, you go ahead, ask your question. Fawaz, are you listening me?
I'm sorry sir, वो हाथ नीचे करना भूल गया।
हाँ जी, अच्छा चलें। So now we are going to, I hope you understand it. हम इस कॉन्सेप्ट को रिपीट करेंगे अगर एक दो स्लाइड्स के बाद भी। We'll repeat it. If you have any question, you can ask me later on maybe. Now, general form of ODEs. How can we write generally the differential equations. Now, if we have this differential equation, which is second order non-linear differential equation. Why it is second order and non-linear? It is because it involves second order derivative, highest order, and the power of y is 3 here. So in each term, y power is not 1, so it is non-linear differential equation. Whether it is linear or non-linear, we can write any differential equation, for example, this one in this way, this one. So what is f? F is a general function where x is the independent variable, y is a function, y dash is the first derivative, y second dash is the second derivative. This is basically, we stop here because this differential equation has two derivatives at maximum in that differential equation. So we stop here. Now this differential equation, in this differential equation, what is the independent variable? It is t. So we write here t y dy by dt or d square y by dt square. We stop here. If somebody has any question, first example is degree 1. Yes, it is degree 1. Now this differential equation we can write at maximum this one. We write dy by dt here even there was no dy by dt here because we take things formally. जब हम इसको might be इसमें dy by dt का कोफिशिएंट 0 हो, लेकिन इन जनरल हम जो हाईएस्ट डेरिवेटिव है वहां तक सारे डेरिवेटिव्स जो है इस नोटेशन के अंदर लिखेंगे. ओके, यहाँ पे y है और d स्क्वायर y by dt स्क्वायर है, लेकिन हम इंडिपेंडेंट वेरिएबल भी लिखेंगे और बाकी सारे derivatives लिखेंगे up to the highest order derivative which is involved in the differential equation. So we can denote this differential equation in this way. So here we have only the first derivative of y. So we can write this thing in the way f of x independent variable y and dy by dx, or we can write it in y dash form. So the maximum term, the maximum derivative in this notation will be the order of a differential equation. Means the maximum order derivative involved in that equation. So this is how we write. Now, for example, in this equation, how many derivatives are there? 3 derivatives. So it is a third order differential equation. Now we can write this notation up to y triple dash. All other derivatives we'll write here in this notation, even if the second derivative is not involved in the differential equation. This is how we can denote generally these differential equations. And this is basically a compact kind of notation which we use to write differential equation in general way. Okay. Instead of writing this again and again, we can simply write this thing. And we say that this is this differential equation. It's a compact notation. So the next on the next slide, and in general, the last one, it is important. In general, the nth ordered ordinary differential equation, the nth ordered ordinary differential equation, which involves the nth derivative, we can write this thing in this differential in this form, from x y dash y double dash up to nth derivative of the differential equation. So in general we write nth order differential equation in this way. If you have any question, you go ahead, ask your question. In the chat there is a question: do we always have to equate to 0? Yes, it is recommended in a general form. If we have any other non-zero term here, we take it on the other side and we write general form equal to 0. This is how we write general form of the differential equation. On the right hand side, you must have 0 here. So there is, yes, Diabetul, go ahead, ask your question.
Sir, ये जो second, I think previous slide में जो second example है, इसमें first derivative तो नहीं है, तो वो हम क्यों लिख रहे हैं?
देखिए, in order to make the notation smooth and same for every differential equation. dy by dx इवन नहीं है, लेकिन इट इज पॉसिबल कि अगर हम इसको डिफरेंशियल इक्वेशन को सॉल्व करें, इंटीग्रेट करें, तो उसमें y फर्स्ट डेरिवेटिव इन्वॉल्व, या आप ये कह सकते हैं कि फर्स्ट डेरिवेटिव का कोफिशिएंट 0 है। इन जनरल अगर हम यहाँ पे एक और टर्म लिख दें 0 टाइम्स dy by dt, तो it doesn't change anything. So now you have dy by dt in this differential equation. जैसे कि पॉलिनोमियल इक्वेशन है, जैसे कि पॉलिनोमियल इक्वेशन है, अगर हमारे पास x स्क्वायर प्लस 1 है, ठीक है, तो इन जनरल हम इसको कैसे लिख सकते हैं, x स्क्वायर प्लस 0x प्लस 1, तो इट इज स्टिल अ सेकंड ऑर्डर पॉलिनोमियल। कोई टर्म अगर मिसिंग भी है तो हम इसको सेकंड डिग्री पॉलिनोमियल ही कहेंगे ना, ठीक है। तो यहाँ पे भी अगर कोई एक सिंगल डेरिवेटिव दरमियान में मिसिंग है, लेकिन हमने हाईएस्ट ऑर्डर डेरिवेटिव देखना है, और जनरल नोटेशन में हमने इंडिपेंडेंट y, उसका फर्स्ट डेरिवेटिव और मैक्सिमम डेरिवेटिव जो इन्वॉल्व है वहां तक जाना है। दिस इज हाउ वी नॉर्मली।
सर ये यहाँ पे,
हाँ बोले
सर यहाँ पे x और लास्ट एग्जांपल में x और कॉमा y भी लिखा हुआ है, तो यहाँ पे y इंडिपेंडेंट तो नहीं, इंडिपेंडेंट नहीं है
लास्ट में
डेरिवेटिव, ये e रेज़्ड पावर x वाली एग्जांपल में, इसके ऊपर
ये वाली, इसमें y है ना, y इज ए डिपेंडेंट फंक्शन, तो फंक्शन भी तो इन्वॉल्व हो सकता है ना डिफरेंशियल इक्वेशन में। तो ये दिस इज बेसिकली योर डिपेंडेंट फंक्शन एंड दिस इज योर इंडिपेंडेंट वेरिएबल, ठीक है। सबसे पहले हम इंडिपेंडेंट वेरिएबल लिखेंगे, फिर डिपेंडेंट वेरिएबल लिखेंगे, फिर उसका फर्स्ट डेरिवेटिव, फिर उसका सेकंड, उसका थर्ड डेरिवेटिव एंड सो ऑन, एंड द डेरिवेटिव जितने भी उसमें इन्वॉल्व, ठीक है। दिस इज जस्ट अ नोटेशन, आई होप you got my point. The question on the chat is it's compact or understanding order and variable you. Yes, you can say that it's a compact notation of a differential equation which tells us the independent variable is this is dependent variable, and this much derivatives are involved in the differential equation, ठीक है। अगर थर्ड ऑर्डर तक डेरिवेटिव है तो ये थर्ड ऑर्डर तक जाएगा, ठीक है। सो दिस इज हाउ वी बेसिकली डिनोट द डिफरेंशियल इक्वेशन। ये पहला इंडिपेंडेंट होगा, ये डिपेंडेंट होगा, और कितने डेरिवेटिव्स हैं इक्वेशंस में, दिस नोटेशन टेल्स अस, गिव्स अस दिस इंफॉर्मेशन। आई होप दैट आंसर्स द क्वेश्चन। Now on the next slide, yes, yeah, there is another general form of the differential equation, of ordinary differential equation. For example, this one, अगर हमारे पास ये differential equation है, तो इसमें जो second derivative है, जो highest derivative है, इसको हम left hand side पे रखते हैं, और जो बाकी सारी terms हैं अगर हम उसको right hand side पे ले जाएं, then we can write this whole differential equation in this notation, in this form. So how do we do this thing? For example, अगर हम इस सारी टर्म्स को दूसरी साइड पे ले जाएं, तो हम क्या लिख सकते हैं, d square y by dx square is equal to sin x dy by x plus 16y cube। तो अब ये किसका फंक्शन है, ये फंक्शन है f ऑफ, ये x का फंक्शन है, ठीक है, y का फंक्शन है, और y डैश का फंक्शन है, दिस थिंग। So in this way we can write this differential equation by keeping the highest order derivative on the left hand side and the remaining terms on the other side. So इस notation में right hand side में आपके पास जो डेरिवेटिव आएगा वो क्या होगा, ऑर्डर से एक लेस तक जाएगा, क्योंकि यहाँ पे फर्स्ट डेरिवेटिव है और सेकंड डेरिवेटिव हमने लेफ्ट हैंड साइड पे रखा है। दिस इज हाउ वी कैन denote the differential equation in this another way. Can you guys hear me now? Ali, can you hear me? Okay, then it's okay. So this is another notation for the ordinary differential equations. What we do we take we keep the highest order derivative on the left hand side, and the remaining terms we take them on the right hand side. So this thing can be written as b square y by dx square is equal to what? 16y. So in general, this is a function of what? F of, first we write independent variable by looking at this, because x is independent variable here, and then y and y dash. यहाँ पे क्या आएगा? जो आपके पास लेफ्ट हैंड डेरिवेटिव है उससे एक कम डेरिवेटिव. So this is how we can denote differential equation also generally. Similarly, you can see this thing. इसमें ये बाकी सारी टर्म उधर ले जाएंगे हम, लेकिन इसमें e raised power x कोफिशिएंट में भी है, इसको फिर डिवाइड कर देंगे हम. ठीक है. So in this term, basically we can write d cube y by dx cube is equal to 1 over e raised power x times sine x d y by dx whole square and minus 16xy. So what we do here, we divided the coefficient of x, this term, on the other side. Now this right hand side can be written as f of x, y, y dash and y double dash. This is how we can write it. I hope you got my point. Now in general, the nth order ODE, इसमें nth derivative को हम left hand side पे रखेंगे, बाकी सारी terms जो हैं वो उधर चली जाएंगी, और जो last derivative होगा इसमें वो क्या होगा? n minus 1th derivative of the function, because the nth derivative we have separated the nth derivative on the left hand side. I hope you got my point. If you have any question, you can ask me. Otherwise, we are going to the next slide, slide number 12. Now, another general form of the linear ODE. In the previous notations, we did not mention that the differential equation is either linear or non-linear. In the previous slide, in the previous notations, the differential equation can be linear or non-linear. Those were the most general notations of the differential equations. But in those notations, we can see the order of a differential equation. For example, in this notation, the order of a differential equation is 3, because on the left hand side, we keep the highest order derivative. Whereas on the previous notation, this one, we write the highest order derivative here. This can tell us the highest order derivative involved in that differential equation. But this notation doesn't tell us whether a differential equation is linear or non-linear. What is its degree? It doesn't tell us. Now we are going to define another notation, this one. This is basically the general notation for a differential equation of nth order, and the differential equation is also linear differential equation, because in every term the power of y is 1. You can see this thing. In each term, the degree, or you can say power of y, is 1. So it is linear differential equation. And as it involves nth derivative of y, so it is called nth order linear ODE. So this is nth order linear ODE. I hope you got it. Now, what is the notation? Notation is let me clear it once again. This one. Here, the coefficient function is only the function of independent variable. Now, this is your nth derivative. Here you have another coefficient of x, independent variable. Here you have n minus 1th derivative, and so on. A2 of x, second derivative, A1 of x, first derivative, A0 of x, y, and you have an independent function here, g of x, which is the function of independent variable. If we take the special cases where these variables are basically, they are variable coefficients a, k, and they are only the functions of x. They cannot be functions of y, because y is a dependent variable. So keep this thing in your mind. Now, special cases which are important is the first order linear ODE. Why this is first order linear ODE? Because it involves only the first derivative and the coefficients are variables of functions of x only. Here we have 1, here we have 1. So in each term, the degree of or the power of y is 1. So it is linear and it is maximum order derivative is 1. So this is first order linear ODE. Now this is what it involves second order derivative. It involves second order derivative at maximum. So this is second order ODE and in each term the power of y is 1. So it is linear. So what we call it, it is a linear second order ODE. Someone has asked a question in chat. Mohammed Abdullah, yes, go ahead, ask your question.
सर इसके अंदर सारे जो x हैं उनकी पावर 1 है, पर अगर 1 से ज्यादा पावर हो x की तो उसको किस तरह इस फॉर्म में लिखेंगे?
देखिए x की पावर डजंट मैटर, x की पावर डजंट मैटर, इसको हम लिख सकते हैं x स्क्वायर dy by dx plus you can say x9y is equal to maybe sin x or plus x square. यहाँ पे x की पावर नहीं देखनी, x तो कोई भी फंक्शन हो सकता है a(n) of x या a1 of x, इट कैन बी एनी फंक्शन, ठीक है, इसमें पावर कोई भी इन्वॉल्व नहीं है, y नहीं होना चाहिए बस इसमें, y की पावर 1 है यहाँ पे और y की पावर 1 है, x की पावर यहाँ पे 9 है, बट इट डजंट मैटर, it will still be a linear first order ordinary differential equation. Okay, we don't see the coefficients of derivatives, ठीक है, we see at y की पावर 1 है, यहाँ पे भी 1 है, यहाँ पे भी, तो ये लीनियर है. Whatever the coefficients are, we don't care about the coefficients until they are functions of x only. अगर यहाँ पे यूं होता y square dy by dx plus x5y is equal to some function. तो अब देखो यहाँ पे y है, y की पावर 2 है और यहाँ पे 1 है, तो टोटल पावर कितनी होगी? 3. ठीक है, आई एम गोइंग टू राइट इट अगेन. अगर हमारे पास y स्क्वायर है और dy by dx है, तो यहाँ पे पावर y की क्या है? 2 है और यहाँ पे 1 है, टोटल पावर कितनी है इसमें y की? 3 है. सो इट इज नॉट लीनियर, ठीक है, it is first order but not linear. So in general, first order differential equations are written in this way. First order linear ordinary differential equations are written in this way, and this is the general form of linear second order ordinary differential equation. I hope you got my point. What is a? A is some function of x. These are coefficient functions. जैसे कि अगर हम यहाँ पे लिखें यूं x square dy by dx plus x power maybe 5, y is equal to 0. Now what is this? This is your a1 of x, which is a function of x, and what is your a naught of x? It is x5. I hope you got it. These coefficients are basically functions of x in the differential equation. Now, if we look at this thing, the dependent variables, ये क्यों linear हम इसको कहेंगे? क्योंकि dependent variable जो हैं, sorry, this one, yes, हाँ, dependent variable जो हैं, इनको हम linear को कहेंगे कि dependent variable y and all of its derivatives are of first degree, means इसकी power 1 है. That is the power of each term involving y is 1. All the coefficients a of x, they depend only on x. This is what I have written here. In coefficients में x होना चाहिए सिर्फ, y नहीं होना चाहिए, ठीक है? Then they stay linear differential equations. I hope you got what are the linear, general linear ordinary differential equations. This is the nth order, the first one. This is the first order. This is the second order linear differential equation. Now we are going to discuss the examples, further examples of linear differential equations. Now you can see here that this one, power of y is 1, power of y is 1. So it is, this differential equation is linear because in each term y has power 1. In this equation, power is what? Y power is 1, y power is 1, y power is 1. So it is again linear. Now here also in each term y power 1, y power 1, y power 1, so it is linear. Now in the examples below you can see here the first term y की पावर तो 1 है, लेकिन यहाँ पे भी y इन्वॉल्व है. ये आपका जो कोफिशिएंट फंक्शंस है जो कि a, आप इसको a1 ऑफ ये अब x नहीं है, अब ये y है, a1 ऑफ y है. सो दिस डिफरेंशियल इक्वेशन इज नॉट लीनियर. ठीक है, यहाँ पे इस डिफरेंशियल इक्वेशन में साइन y इन्वॉल्व हो रहा है. अब y की पावर 1 नहीं है, क्यों? क्योंकि y एक, अगर इसका सीरीज फंक्शन लिखे हम तो y sin y की सीरीज लिखें तो उसमें y क्यूब भी आता है, y5 भी आता है, एंड सो ऑन. सिमिलरली इन दिस डिफरेंशियल इक्वेशन यू कैन सी y की पावर 2 है यहाँ पे इस टर्म में, तो ये लीनियर डिफरेंशियल इक्वेशन नहीं होगी, ये इसको नॉन लीनियर. आई होप यू गॉट इट. नाउ लेट्स गो टू द नेक्स्ट स्लाइड. This one. Now we use different notations for first order ODEs. Different notations for first order ODEs. All the trigonometric functions will be non-linear if they appear in the differential equation as a function of dependent variable, not the independent variable. Okay, then the equation will become non-linear. Now, the general form of first order ODEs, the general notation. Oh, we can take this thing here, yes. Linear ODE of first order can be written, why is this so? Let me go to this one, yes. This. So फर्स्ट ऑर्डर ओडी को जनरल नोटेशन हमने प्रीवियसली देखा था प्रीवियस स्लाइड पे कि ये इसकी जनरल नोटेशन. इसको हम अगर इस कोफिशिएंट को हम डिवाइड कर दे थ्रू आउट, यहाँ पे ले आए, यहाँ पे ले आए, तो इसका जो फर्स्ट डेरिवेटिव है इसके कोफिशिएंट को हम 1 कर लें, तो वी कैन इन जनरल डिनोट द डिफरेंशियल इक्वेशन, फर्स्ट ऑर्डर डिफरेंशियल इक्वेशन इन दिस वे एज वेल. दिस इज जनरल फॉर्म. This is the standard form of the first order differential equation. You keep this in your mind. What is the general form of first order ODE and what is the standard form of ODE? Now, another notation of first order differential equation is this, that you just cross multiply the differentials. Yes, there is a question. Standard form is what? You just divide the whole differential equation with the coefficient of this dy by dx. dy by dx के कोफिशिएंट से डिवाइड कर दें, यू गेट दिस. अब इसको हम p of x कह देते हैं, इस फंक्शन को. आप इसको p of x कह दें, इस फंक्शन को आप q of x कह दें, तो हम इस पूरी डिफरेंशियल इक्वेशन को इस फॉर्म में लिख सकते हैं. आई होप यू गॉट इट. Yes, in the questions we have different notations. And you have to remember these kind of general forms and notations of differential equations. ठीक है, तो स्टैंडर्ड फॉर्म में क्या है? स्टैंडर्ड फॉर्म में y का कोफिशिएंट जो है कोई हो सकता है y का कोफिशिएंट, लेकिन स्टैंडर्ड फॉर्म में y का कोफिशिएंट, सॉरी dy by dx का कोफिशिएंट क्या होना चाहिए? 1 होना चाहिए. तो ठीक है, so this is the difference between standard and general form. That is, the coefficient of y dy by dx is, it may be different in general form, but in standard form its coefficient should be 1. Now this is another form of first order differential equation, क्योंकि first order differential equation अगर हमें इस form में given है, ठीक है, for example this one, dy by dx is equal to x by y, for example. अब हम इसको स्प्लिट अप कर सकते हैं, y dy is equal to x dx, and then we can take this thing on the other side, we can write y dy minus x dx is equal to 0. So what is this? This is your m function, and what is this? This is your n function. So generally, we can write first order differential equation in this form as well. Okay, there's a question in the chat. Yes, go ahead. What is the question? Standard form, can you repeat the standard form? Standard form में देखिए बेटा, जनरल फॉर्म में क्या है, y का कोफिशिएंट कुछ भी हो सकता है. अगर y का कोफिशिएंट dy by dx का कुछ भी कोफिशिएंट हो सकता है. स्टैंडर्ड फॉर्म में क्या है कि इसका कोफिशिएंट 1 बनाना है आपने. कैसे 1 बनाएंगे? आप इससे डिवाइड कर दें बाकी सारी टर्म्स को, तो यहाँ पे खत्म हो जाएगा. अब इसको आप p of x कह दें, इसको आप q of x कह दें, another function, कोई भी और फंक्शन हो जाएगा ना. ये मसलन आपके पास x dy by dx plus 2y is equal to 9 लिखा हुआ है. तो ये क्या है? ये जनरल फॉर्म है. स्टैंडर्ड फॉर्म क्या होगी? आप dy by dx के कोफिशिएंट को डिवाइड कर दें, so it becomes 2 by x, y is equal to 9 by x. So ये एक डिफरेंट फंक्शन है, ये एक डिफरेंट फंक्शन है. इसको आप p of x कह दें, p of x, इसको आप q of x कह दें. ठीक है. So what this differential equation becomes now, dy by dx plus p of x, y is equal to q of x. So this is your standard form. I hope you got it. Yes, there's a question in the chat. Okay, you got it. That's great. Now this is what, this is basically another form of a first order differential equation. We have differential of x here, and we have differential of y here. The coefficient of dy could be any function of x and y, and the coefficient of x could be as well any function of x and y. For example, I have written here this example, this one, because it involves dx and dy. ठीक है. तो इसमें कितने डेरिवेटिव्स इन्वॉल्व हैं? ओनली वन डेरिवेटिव. बिकॉज अगर हम इसको दूसरी साइड पे ले जाएं, तो और दूसरी साइड पे ले जाके जो इसका कोफिशिएंट है उसको उधर डिवाइड कर दें, तो हमारे पास सिर्फ dy by dx आ जाएगा. dy by dx is equal to some function of x and y. ठीक है, इस तरह का फंक्शन आ जाएगा. सो इसमें कितने ऑर्डर डेरिवेटिव्स इन्वॉल्व है? फर्स्ट ऑर्डर. सो it is first order differential equation. Similarly, you can write this one. This is again the first order differential equation, because अगर हम इसको दूसरी साइड पे ले जाएं तो ये क्या बन जाएगा? x y dy is equal to what? Minus y plus 1 times dx. अब इसको उधर डिवाइड कर दें x y को, और यहाँ पे x y को यहाँ पे x y को डिवाइड कर दें. What do you get? You get dy by dx, और dx को इधर डिवाइड कर is equal to minus y plus 1 divided by x. So what is this? This is your function of x and y. So this is your first order differential equation. So in general, sorry, I should not be here. Clear, and I should be here. Yes, this one. So हम बात कर रहे थे कि इसको हम फर्स्ट ऑर्डर डिफरेंशियल इक्वेशन के फॉर्म में लिख सकते हैं. I hope you got my point. And how can we write this thing? We can take this term on the other side, and we can write dy by dx is equal to minus y plus 1 divided by xy. So what is this? This is your function of xy. So this is basically first order differential equation. So these are few notations of the first order differential equation. I hope you got it. If you have any question, you can ask me. Otherwise, we are going to move forward. Now, what is the solution of a differential equation? Next definition on slide number 15. Any function phi, where phi is any function, or basically phi could be a function of x if x is the independent variable in the differential equation. Phi can be a function of t if t is the independent variable, because this function phi should be, wait, this one, yes. Phi could be function of the independent. Phi should be a function of independent variable. So any function phi defined on some open interval I, it should be open, and possessing at least n derivatives that are continuous on I, which when substituted into nth order ordinary differential equation reduces the equation into identity, is said to be a solution of solution of the differential equation on that particular interval. This is the formal definition of the differential equation. So let's discuss this definition with the help of examples. On the next slide here, I'm going to give you the examples. What is a differential equation? Sorry, what is the solution of a differential equation? Now, in this examples, we are given two equations, 1 and 2. These are the functions which we are going to prove that these are solution to these differential equations. Now, this thing can be written in this form. Y is what? Phi of x. And here, y is what? Phi of x. Because x is the independent variable. So we are going to prove that this function is solution of this differential equation. What we do here, we insert this function on the left hand side and on the right hand side. So on the left hand side, क्या होगा? आप इसका एक डेरिवेटिव लें तो क्या आएगा? 1/16 as it, और x power 4 का डेरिवेटिव क्या हो जाएगा? 4x cube. So it becomes 1/4x cube. Now right hand side पे अगर आप इसको पुट करें right hand side पे, तो आपके पास क्या है? x y power 1/2. y की जगह आप क्या पुट कर देंगे? 1/16 x power 4 की पावर 1/2. It becomes 1/4 x square. अगर इन दोनों को मल्टीप्लाई करें, you get 1/x cube again. So इसमें right hand side और left hand side दोनों क्या होगी? Same होगी. So the equation, this equation reduces into identity. Means left hand side is equal to right hand side if we insert this function into this differential equation. So this is basically the solution of a differential equation, and this solution is valid on this interval, which is the set of real numbers. It is possible that a solution is valid or it holds on a particular interval, for example, -5 to 5, or you can say 0 to 1, or many. So a solution can exist for a differential equation. Number one, if this function satisfies this differential equation, and that solution should be valid on some interval, for example, this one or this one. But this solution is valid on the whole set of real numbers, which is -infinity to +infinity. I hope you got what is the solution of differential equation. Now, if we want to prove that this function is a solution of this differential equation, what we do, I have written this, I think, on the next slide, this one. Now, on this slide, we are going to prove, yes, there is a question in the chat. Just give me 1 minute, I'll wind it.
Sir, time ho gaya.
1 minute, let me finish this. So now we are going to prove that this function is a solution of this differential equation. What we do here, we take the two derivatives of y, sorry, one derivative, two derivative, because here we have first derivative, here we have second derivative. So first derivative लेंगे तो आपके पास ये आ जाएगा. You use the product rule here. Second derivative लेंगे तो ये आएगा. अब फर्स्ट डेरिवेटिव को आप यहाँ पुट कर दें इसकी वैल्यू, और सेकंड डेरिवेटिव की वैल्यू आप यहाँ पुट कर दें लेफ्ट हैंड साइड में, ठीक है, और y की वैल्यू भी आप यहाँ से उठा के पुट कर दें y में. आफ्टर सिंप्लीफाइंग ऑल दिस थिंग यू गेट 0, which is equal to what? Which is equal to right hand side. So this function reduces this equation into identity. This function reduces this equation into identity, means left hand side is equal to right hand side. So this is the solution of a differential equation. I hope you got it. if you have any question, go ahead, you can ask that question. If you have any question, you can ask that question. Otherwise, I'm going to stop here, and the remaining things we'll discuss in the next lecture. Next lecture, we'll discuss, in fact, types of solution. In this lecture, we discussed the last thing, what is a solution. In the next lecture, we'll discuss types of the solutions. So thank you very much for today. I'm going to stop the meeting here. See you guys in the next lecture. Thank you very much.